Hello, and welcome back. In this tutorial, I'm going to be talking about strings and string manipulation in C. Up to this point, we haven't talked much about strings. We have used them, and while that is useful as far as grabbing input from the screen and taking those strings and displaying them, it's just not enough. Many times you have to do certain things to strings, like compare them. For example, if you have password and you want to compare a password to another password, well, you want to compare the strings. Or if you want to get the length to make sure that, for example, the password is long enough, you would need to get the length. Sometimes you need to copy a string into another string, and you have to do these things. These functions can be found in the string.h library, and you notice I included the string.h library up here. I've also included the stdlib library because I also wanted to talk about some of the functions in the standard library, which are A to I, A to L, and A to F. And these functions are for taking a string value. For example, a string that is a numeric value, for example, like we have here 43, it's a string, and we want to convert it to actual numeric value because maybe we want to do math. Maybe it's a score or something like that. So let's go ahead and get started. Let's start off with the string length function. So for the string length function, we have this, okay? And as you know, as you can remember, to define a string, we just define it simply by this. Let's go ahead and comment this out because we're not interested in this at this point. And let's go ahead and display the string. So we have this string, and let's start off with this password too. You know that a string is really an array of characters, which can be displayed as something like this if we were to do it. So this string and that string are the same, except there's one more character, and that is the terminating character. So when we do this, these two are the same, and there's a way to compare that. So when we print them out, you should see the same thing, and we have our printf function here, and we go ahead and run this, and we're going to compare strings. Let's call that function. And you notice that they say cat1 length 4, cat1 length 4. And so they're the same. How can we be for certain that they're the same? Well, there's something here that we could do. And let's take this. Let's place our comment here. And if we were to compare them, we can use a function out of the standard library here, which is string compare. It's in string.h. And we can compare them and run it. And you notice that this function takes two strings, a string 1 and a string 2, and it returns an integer. Notice also that there's a const, which means that your string is safe. It's not going to be changed in that function. The value will not be changed. So it's just comparing this string and this string, but it returns an int. And what does that mean? Well, when the strings are equal, it's going to return 0. So in our case, the passwords are the same. Let's go ahead and get rid of this. Or let's just go ahead and create another one. Password 3. And let's compare password 1 and password 3, and they are the same. What if I instead had a different length and I compare them? They're still the same, and the reason that it compares them as being the same because after the 1, even though our array length is 10, after the 1 it doesn't matter because it finds this character and says, oh, I've reached the end, these passwords match. Now keep in mind that the string compare is case sensitive. So for example, uppercase cat1 or even this cat1 is not the same thing as this cat1. When we run it, the passwords are not the same. Which brings us to this portion of the code. And let's get rid of this. And since we changed that, we have to change this also to password 3. And it actually tells us passwords are not the same because they're not. They didn't compare. But it actually tells us also that password 2 is greater than password. Let's change this also to password 3. Let's run it again. It tells us that password 3 is greater than password, than just simply password. But that is because uppercase has a lower ASCII value than lowercase. All uppercase characters have a lower value than their uppercase counterparts. So password 3 is actually greater. What if we had something more obvious? Let's just say AAA and BBB. And notice it doesn't even matter where the difference is. It could actually be BBA and BBB. And now password 3 is greater than password. Password 3 is greater than password. So that means that this is greater than that because of the A at the end. It knows how to compare it. Basically, it's comparing it in alphabetical order. So with that said, now you notice that the string compare here uses the greater than symbol. So string compare is going to return an integer. If they're equal, it's going to return 0. If they're not equal, it's like, think of it as putting the symbol here. Password is greater than password 3. But in this case, that's not true because password 1, which is password, is actually less than password 3. So password 3 is greater. So think of it like this. If you were to put the symbol, password is lesser than password 3, and it returns a value lesser than 0. It could be 1, and it could be not be 1, but let's just say, let's not even worry about it. We always compare against 0. If it's greater than 0, like this, that means this is greater. If it's less than, then this is greater. You can also think of it as, pointing to the greater one. This arrow pointing to the greater one. If it points to the left, this one's greater. Points to the right, this one's greater. So if we do this, and right now it's falling into here, but what if we made password greater? We could do it like this. And now password is greater than password 3. That is your string compare function. Just keep in mind that it must be a string and in order to compare, and keep in mind that it's also case sensitive. There's ways to do comparisons without taking that into effect. For example, if you had CCC and uppercase CCC and you didn't really care about case sensitivity, there's ways to do that. I'm not going to cover that here. I can leave that as a challenge for you to find and to execute. Just keep in mind there are 2 upper functions and 2 lower functions, so you can actually do that. So that is the comparing string function. And notice also that I had the length, and string length is to get the length of string. So there it is, and those come out of the string.h library. String length, string compare. We haven't talked about string copy, so let's talk about that one. There may come a point where you want to copy a string. So here we have, for example, a name. We have Fu, Joe, and we have last name Smith. If we want to copy the value from any one of these into that, we call the string copy function. The one thing is that we must make sure that the name, this guy, the name array, is long enough to hold a value. So as long as it's long enough to hold a value, we're okay. And even if it's not long enough, it may actually work, but you can run into some serious issues. You should always make sure that whatever you're going to copy into, that you have enough space to copy whatever you're copying into it. Usually when you work with data, you're going to have some kind of minimum and maximum limits that you can set for your strings, so just keep that in mind. So in this case, we're going to copy foo, which is Joe, into name, and you're going to see the value. So you're going to see name, and let's go ahead and do that. Let's call the function copy. Change this. Let's get rid of all this white space. So when we run copy, you notice that Joe got copied into name. And so name has Joe and foo has Joe. That is your string copy function. Keep this in mind. Keep in mind that you can't do this. You cannot simply say name equals foo. You cannot do that. Because what you're actually doing, it'll actually work. It'll compile. Let's see. Name and foo. It doesn't like it. I thought it would because it's a pointer, but apparently it does not like it, so you can't do that. Assignment to expression with array type name foo. So it doesn't even like it, so you can't do that. So let's get rid of that. You can't do that. You must use string copy like this. Next on our list is the string cat. And the string concatenation is basically, like it says, concatenation. And you have the destination and you have whatever you're going to copy. So for example, if you had a name and you have a name and you have a full name and you have a first name and a last name, you want to copy the first name into the full name, and then you want to also copy the last name into the full name. You would take your name and copy it into full name, and then you could call it again with last name and copy it into that. Notice also that these functions don't have the const keyword. So this one here has the const behind it. That means you cannot change this value. That kind of lets you know which one is getting copied into what, because this is going to change. Also, when you do this, it returns a pointer to the same thing as this. So it returns a pointer to that same thing. I'm not sure why they did it that way, but I guess matter of convenience. So I guess in case that you didn't want to, have to wait on it, you could actually write string copy and it'll have that. So as a matter of fact, we can try that. So let's just do that. And so let's do that. And notice that in string compare, you have const for both, means they're not going to change when they compare. So string copy, they do that. So if we do copy, we could actually even do copy here because it returns a value. We could say string copy name foo, and our copy still works. Okay, well, hold on a second. Main warning initials that makes integer 56. It doesn't like 56. Oh. Implicit declaration of function string copy. We didn't do a copy. We have a typo. And you notice that it worked also. So I guess since it's a function and it returns a value, you don't even have to wait till it comes back and store the value somewhere. You don't have to wait for array. But this and what it returns is the same thing. They're the exact same thing. And I bet you if you look at the pointers, you would probably get the same value. We're not going to look at that right now though. So let's just keep that in mind. So let's do that. And so we have the copy. So let's take a look at the concatenate. And we have an example here. Concatenate. We will use the string cat function. And notice you have a destination and you have a source. this gets copied into this, and it returns the full thing. So this and this are the same thing. It returns the destination. So just like copying. So we do concatenate, and we can call it from our main. And what we can expect in this example, we have a first name and a last name, and we are going to copy those into name. So we're going to copy Joe into the name, and we're going to copy Smith. So we call the string cat, and it's going to copy first name into name, and then we're going to copy a space to separate from first name from last name, and then we copy the last name, and then we go ahead and display them. And keep in mind we're using the %s to display them. So let's go ahead and concatenate and see what it does. Notice first name, last name Smith, full name Joe Smith. Notice that initially we didn't have anything in full name. We just have an initialized array with a length of 50, but it has nothing in it. After we copy everything into it, then it has that. So that's the string cat, and very good for joining strings. The final piece to this, to string manipulation, is string talk. Many times you have records that, for example, may be comma delimited. They could be delimited by anything really, but comma delimited is very, very common for flat file records. So you may want to split those records up, and you can't just do it in one function. I mean, you can write your own function that does it using the string talk. And basically talk just stands for token. So what you want to do is, in this example, we have, for example, Joe Smith, age 43, and he lives at 2333 Sun Street, Chicago, and in the state Illinois. Notice I have this comma delimiter, and I have the comma delimited. So what I want to do in this case is take that and split it up into individual pieces. So what I can do here is, the first thing I got to do is let's take a look at the API. So the string talk says that I must pass the string source and then the delimiter, and then it gives me the token. The thing about this one though is that you have to get, it only gives you the first one. It gives you the first element, and once you've initialized it, then you can take that element, which is just really a character array, and it gives you the first word. So then you use the null, and null we haven't covered yet, but null is defined also in string.h, and I think it's defined in other libraries. So just know that null represents that null character. So when you do that, it gives me the first word. So I say while token not equal null, I go ahead and print out that token, and then I can take and I can go ahead and continue getting tokens, and this is the way you call it on the next one. You pass null and you pass the delimiter, and then it'll just keep printing whatever's there until token returns null. Now let's say, for example, I wanted to actually split this into variables. I could take something like this where I have an array of a multi-dimensional array. So I could say something like this. And I could say tokens, right? Because maybe I just don't want to print them. I want to actually store them somewhere. And I can say tokens, you know, I can say 20 or whatever, or 30. So this gives me an array of pointers, but I can also do something like this. Let's say that I have a multi-dimensional array. I have how many items? 1, 2, 3, 4, 5, 6, 7. So I can just do a 10 by 10. Let's just do a 10 by 10. Make it simple. Maybe more than 10 here. Okay, so let's go 30. leave it like that. So we have that. And what we can do, instead of doing this, we can actually leverage our string copy. And we want to copy into tokens. And we want to copy into tokens I. We want to copy the token. And we have to increment our I. We could do it in there, or we could do it out here. I plus plus. And if we have int I equals 0, we can actually have tokens, and we can actually also, after we copy it, we can print our tokens. Let's see if this works. Did we call tokenize? We haven't called tokenize. Oh, we misspelled it here. And you notice now I've actually stored in my array of elements, I've stored Joe. In 1, I've stored Smith. In 2, I've stored 43. In tokens 3, I've stored some street in Chicago. So this is a way that, you know, maybe you just don't want to display them right to the screen. Maybe you want to save the values, separate it, and you have that. So there you are. And you can see that it actually copied the exact same thing, because we can do this to show that it copied exactly what we have here. Notice that it copied the exact same thing. So that's your tokenize. And this allows you to do the limited records out of, you know, a file or a record or whatever you may have. You can actually take and do certain things with them. So as an example, 43, which takes us to the next one, tokens 2 is 43. We could actually take tokens 2 and convert it to an integer. So let's say, for example, we have an integer, age equals, and we have a to I here out of the standard library. So we can say a to I, and we can say tokens, and we know tokens 2, index 2 is our value, and then we can print f. And we see that we converted it. And so I'm not even going to cover all the other, the A to I, A to F. You can see A to L is long, like if you had a longer number that you need to store, because you know it's twice as long as the integer. It's 8 bytes, and you have A to F, which are converted into a float. So you know, if you had something like, you know, averages or something like that that has decimals, then you would use A to F. You wouldn't necessarily do that. Just be careful when you do A to I, because if it doesn't have a value, you may run into problems. So for example, if you did something like where you have, let's say, for example, we said string copy tokens to, and we say, let's say, for example, if we have 45, it's fine, right? So it does that. But what if you have some character and it gives us a 0? It can't convert it over. So just be careful with that. Or even this, you know, it doesn't give us anything, so just be careful. It doesn't error out on you, but it'll end up giving you 0, because it doesn't know how to convert what you're passing it. So same thing with, for example, if you did the float, if you had a float and you do A to I, well, it gets truncated to an integer because it can only convert it to an integer. So that's really everything I want to cover this time around. And you can pause this video. You can look at all the code here. So you have the compare strings here. You can look at it and pause it there. You have the copy here, concatenate here, and you can pause. Tokenize here, and there you are. Now the libraries, and I've included the links here. Tutorials point is a really good reference to seeing what's in the string age, and there's a lot more in these libraries. String age, stdlib, there's more in those, so you can look at them and you can see what's available there. And so these are the ones in string age, and these are the ones in stdlib.h. And remember, you just include your libraries when you want to use them, otherwise you will get an error. And you can look at the references there. I will also include a link to this code in the description of the video. So when you look at the description of the video, if you want to actually go and just grab this code and play around with it, I will provide a link since it's all online. And so if you like this video, please subscribe, like it, share it, do whatever you want with it. And thanks for watching. Until next time.